Okay. Now, here's what we're going to do. We're going to put this as 15. This is 45. This one as. This one as 105. How do I know it's 105? You add them together and you divide by 2. So 90 plus 210. Oh, sorry. 90 plus 120. Divided by 2. 105. Yes. Yeah, exactly. Yeah. No worries, whatever way you want to do it. Now, lads, here's next thing you're doing. Everybody looking? Okay. 15 times 1. 15. 2 times 45. 10 times 75. Okay. 7 times 105. Yeah, well done. 5 times 135. I think it's 675, but I definitely use my calculator to check that out. I'm just going to make sure, though. Now, lads, it's important you guys show the work. It's no offense, but it's important that you show this first line, because if you guys just use the calculator and show down the answer, you're either getting 0 marks or 10 marks. Well, if you show the in-between workings, you can still get 7 out of 10, even if you get it wrong. So I'm encouraging you to do what I'm doing here. Now, how many people are there? I think it tells us. 25. Well, even if we didn't know that, how would we figure it out? Yeah, add them all up and we should get 25, shouldn't we? All right. Now, we put over 25, don't we? Okay. Sorry, 1 second. 25. Now, I'd expect an answer somewhere in the middle, somewhere from the 60 to 120 region. Somewhere in there. Let's find out. Okay, so it's 15 plus what? Plus, yeah, 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 and divided by. Whatever goes into the calculator gets written into your answer on your test. We get 90.6 as our answer. Well done. Awesome work. Well done. That's 90.6, and that would go for big marks, that would. You okay with that? Now, lads, next thing. Explain why a histogram is suitable chart to display the data. Histograms are used for continuous data. Does anyone know what continuous data is? Anything that's measured. Tire pressure, time, weight, height. What would you not use a histogram for? Grades. A, B, C, and D. You'd use a bar chart for that. Yeah? Or for example, how many of you have 3 brothers, sorry, 3 siblings? It's either 3 or 4. It's never in between. Do you get what I'm saying? So that'd be discrete data. It's the number of siblings you have. Discrete data and categorical data, you use bar charts. All right, guys. Lad, your job now is to draw a histogram for me. Off you go. A histogram. And you're going to use this data here. Look at the board. Hi. 0, 30, 60, 90. Has to be the same gap, doesn't it? 120 and 150. And on the other axis, it has to go as high as 10, doesn't it? I've made a mistake. Can anybody tell me what would be the mistake? I haven't written something in. What do I need to do? That's number of students. And then on the bottom is number of minutes. Okay. And so you guys got to draw this chart now in a second. I'll do the very first one for you. Actually, I'll do one of the middle ones. Tell you what. I'll do 90 to 120 for you. 90 to 120 is 7. All right, I'm going to pause it here. Looking. Okay. Did anybody get 1 for the first one. Then you get 2 for the second one. And then 10 for the third one. Gonna make a mistake. Can somebody tell me where I would have lost the mark? Yes. Yeah, histograms overlap while bar charts generally don't. Is that okay? And the last one. What's it, a 5? Okay, 5's halfway between 4 and 6. There you go. Happy days. That's our histogram. Are you all okay with that? Alrighty. Now, next thing. What we're going to do. I'm going to make us draw a pie chart of that in a second as well. Actually, go on. Might as well do it now. Lads, shall we draw a pie chart of this as well while we're at it? Why not? Well, lads, you're going to need your kit for Thursday, aren't you? Now, lads, what we're going to do is we're going to set up a pie chart for ourselves, and here's how you do it. You grab your compass, like so. You pick a point to be your center. You grab your compass, and you make a circle. Okay, usually, if it's given to you in a test, the circle's usually provided. Okay, here it is, fairly big circle. And I'm just going to draw one line just going directly to the right. Now, what we're going to have to do next, guys, is we're going to have to change this into... Shh, lads, you looking? We're going to have to change this into degrees. Now, here's what you're going to do. Okay, looking? 0 to 30 is 1 out of 25 people. Would you agree with that? And 1 out of 25 people, multiply that by 360. Is that okay? Next one. 30 to 60 is how many people? 2 out of 25 multiplied by 360. Okay. 10. 10 out of 25 multiplied by 360. Okay. 10 out of 25 multiplied by 360. And finally, 120, 150. 5 out of 25 multiplied by 360. Okay, and we'll pause there for a second. You have the calculator part of this question, which you're going to multiply 1 out of 25 by 360. And you're going to keep going after that. You're helping me. Make sure I'm right. I think the first one's 14.4. Next one. Because it's double it, isn't it? The one after that is 10 out of 25 multiplied by 360, which is 144. Okay. Next one, 7 out of 25 multiplied by 360 is 100.8. 72. Now, guys, we want to make sure, do you know when we round them, we want to make sure that they add to the right amount. So we might just, if we round two of them upwards, so look at this, guys. What do you think happens? You listening to me? What do you think happens if I call this 14 and I call the two of these 29 and 101? What do you think happens? It might do. Let's add them all up and see if it works out. 14 plus 29 plus 144 plus 101 plus 72. It has to add up to 360, doesn't it? And it does actually add up to 360. We're okay. So here's what we're going to do. Yes, sir. What? Yeah. Now, guys, here's what we're going to do next. We're going to get our protractor and we're going to start measuring angles. Okay. Let's start off small. 14 degrees. Halfway between 10 and 20, roughly. Sort of level, just below halfway. That's about 14 degrees. Okay. What's we're gonna have to add on? We're gonna add on 29 now. Look at this. Gonna move it. Now we're gonna do 29. Just under the 30 mark, isn't it? Happy enough with that? Let's keep going. Spin again. Okay. What's this one? 144. Okay. There's 10, 20, 30, 40, 50. You have to go all the way over here. Sorry, I messed that one up. I ran out of range. But in between 140 and 150, just slightly below halfway. Okay, next one's 101. I'm gonna go up. I'm gonna go this way here, all the way down, and we go for 101. There's my 10, 20, 30, 40, 50. There's 80. There's 90. There's 100, and there's 101. Now, lads, I won't get anywhere near full marks for this. Can anybody tell me why? Okay, so what's the first one? 0 to 30 and 14 degrees. Next one, 29 degrees and 30 to 60. The biggest one, which is, I did actually work. I added them up to make sure. Yeah. Yeah, I actually added up to 360. Doesn't always, but just I checked it. And what's that? 144 degrees. Okay, lads, what's the next one? 90 to 120. 101 degrees. Okay, and then the last one. Yeah, that's not too bad, is it? Draw the data on the histogram. Great. He wants us to find the median. Now, the median's the difficult one. Here it is, isn't it? And sorry, I just want to grab this back here. So this is the median. Now, lads, how many people are there? Huh? Here, median is the hardest question if you're asked one of these. I'll explain why. So the median is really awkward for the following reason. There's 25 people, agreed? Now, who's the middle person of 25 people? Divided by 2? 12.5 rounded up to 13th. 25 is an odd number. Odd number only has one person in the middle. If it was an even number, it'd have 2. So, for example, if there was 26 people, it would be 13 and 14. But in this case, it's number 13. Now, here's the awkward one. Ready? The first person is in here. Number 1 person's here. Number 2 and number 3 are located here. Mr. Gilligan. 2 and 3 are located here. Now, where's the next few people? 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way up to 13. The 13th person is actually the last person in this interval. Does everybody see that? So what's the median? There you go. Happy days. That's good. Well done. How do I draw a net of this? This is the base. So this is the base. See the base here? And Sean said something very smart. He said big T and little t, which is very smart. Now, does everybody agree that the base is 6 by 4? It is, isn't it? 6 by 4. Okay, now here's the next one, all right? If I draw another one here, what's linked to the 6 by 4 at this edge here? So I'll draw an edge for you, all right? So look, this here is the red edge. See that? That's the red border. So who else is on that line? 5 and 5 by 4, is it? Yeah, it's 5 by 4. Okay, and that, sorry, I'm up there. That's 5 by 4. Has to be the same width, doesn't it? All right. Now we're technically on, that's the green edge, isn't it? Would everybody be happy that's the green edge? Okay. If you want to keep going with the green edge, what else is attached to the green edge? The top. 4 by 6. Now, do you remember what I said the other day? You're always in a straight line. There's only a gap of 1 between you and the exact same side. So, does everybody see that? That's the green line then? Okay, and that one was? So that was 6 by 4, wasn't it? Now, lads, there's a choice here, right? I'll show you both choices. Now, lads, I'm quickly going to do the for argument's sake, the blue edge. Ever see the blue edge? That blue edge can be this one here. You see it? Now, what's attached to the blue edge? 6 by 5. So, would everybody agree that then I should go 5 down and 6 across? And I think I'm going for small t like Sean asked me to. All right. Now, Sean, we're going to color this a different color now. What about this one here? This green purple edge here. Who's he attached to? No. Huh? 5, is it? 5 by? 5 by what? Yeah, it's a 5 by 6. Okay. Now, lads, do you see the way these two are the same as each other? Yeah? And you see the way these two are the same as each other? And see the way they're only ever separated by 1 in the middle? All right. Yeah. Now, next thing. I can either do big T or small t. Now, do you see this one here? Do you see this one here I just drew there? Yeah, now look at this. Have a choice. I can put it here to make small t, or I can put it over here to make big T. And both answers are perfect. Okay, so for argument's sake, this color here, I'll call it the yellow edge. See the yellow edge? And that's the yellow edge here. Look, keep going here. All right, so would everybody agree that this one is 4 by 5, is it? 4 across and 5 up. Now, see on the graph to the left, it says 5. Now, lads, look at this. We have to do the area. Surface area is next. All right, so look at this. That's 20. How do I know it's 20? And a gap, that would also have to be 20. If that's 24, that's 24 as well, isn't it? And if that's 6 by, what's this, 6 and, sorry, that's 5 and that's 6, isn't it? And what'd that be? 30, and this one here. And then to get the entire surface area, add them up. And you can see that this is quite an easy enough question for you guys. So what's it? 220s are 40, 224s are 48, and 230s are 60. And we get an answer of 148. Now, if this is measured in centimeters, what is it? Centimeters squared. Is that right? Awesome. Lads, look at this. First of all, because it's a straight line, it's not element R or element N or element, it's element R. And it tells you that, doesn't it? Now, imagine I didn't give you this answer. Okay, imagine I didn't give you this answer. All right. And in the test, I want you to ignore that answer. This is the exact question that's coming up on the test. Right? It actually is. All right. Now, here's what I want you to know. Right? Here's the way I want you guys to do the answer, because this is what's called a compound inequality, and you guys weren't taught compound inequality, so you do it slightly differently. And I'll show you now. Ready? You're going to do x is bigger than 0. How do you know x is bigger than 0? How do you know it doesn't include 0? It's a hollow dot. And then all the answers have to be smaller than what number? Now, is x smaller than 4, or is it smaller than or equal to 4? Yeah, but it's filled in, so it's smaller than or equal. Now, I'm going to show you another one. I'm going to show you it's a very similar question. And here's what it looks like. Ready? Now, once again, a very, very similar question. Okay, here we go. Now, this time, there's an arrow here. And what does that mean? The arrow. Okay, so that means your x values are bigger than 0. But that's just your answer, because it's going to go on forever. It doesn't stop, does it? Yeah. Now, lads, what happens if I fill this in? What happens if I put this in? Like this. Yeah, perfect. Right, next thing. Ready? Next thing we're going to do. Right, I'll try another one of these. Right, be slightly different. Right, here we go. -2 included. -1, 0, 1, 2, 3. Shaded in from here all the way to here. Okay, so what element is it again? Element R, Z, or N? R. Excellent. Okay, next thing. How do I write this? Anything bigger than what number? Anything bigger than -2. Is it bigger than -2, or is it bigger than or equal to -2? Why is it bigger than or equal? You should pay attention, Sean. You should. Might get it right on Thursday. Okay. Now, lads, what about this one here? So less than 3. Now, lads, if I modify this question and I modify it by putting in the 3 like that, excellent. We cool? This time I'm going to change the full stop here. I'm going to change it into an arrow. What does that arrow mean? So how should I change this answer? It's still R, but how do I change the answer I have to the right? Does it stop at 3? That's gone, and that's your answer right there. Cool? Either it stops or it doesn't. If it has an arrow, it doesn't stop. If it does stop, it'll have 2 parts to it. Okay. Well, I wouldn't. You literally have 3 minutes left. All right. Now, lads, look at this really quickly. 3 multiplied by, for argument's sake, x minus 5. Smaller than or equal to 2 times x plus 3, right? X is an element of Z. Ready? Okay. I have no way to make this number line. Step 1, multiply it out. So what do we get? Less than or equal to? Okay. Move the x's to the left and the numbers to the right. Okay. So 3x take away 15 plus 6. X is smaller than or equal to what? 21. Well, lads, look at this. Okay. Now, how far does this go? It's element Z. So how far does this go? It goes on forever. Minus numbers are included as well. So I'm going to put in dots this time. Why am I putting in dots? Yeah. And then I'm going to put in a line here. I'm just going to say goes on forever. No, because it's not element R. Fractions and decimals are not included. All right. If this was element N, I'd have to write it all the way back to 0. I'm not going to do that. So I'd actually have to stop it all the way back at 0. Do you get what I'm saying? But it wouldn't be like 21. It'd be something like less than 5, just so you don't have to go that far. Yes.